Hello, so let's continue with section B. The question reads, write the bond line formula for each of the following compounds. So when we look at the first compound is 1,4 dichloropentane. First thing, identify the parent chain or identify the parent name. So the parent name is pentane. Pentane is implying how many carbons? 5, right? So I'll do 5 carbons. 1, 2, 3, 4, 5, right? After I do that, put the attachments where they are supposed to be. So I'll use a red pen, although you're supposed to use the same pen, but then for the sake of making it crystal clear. So according to the name, at position 1, right? And at position 4. So 1, 2, 3, 4. And at position 4, I have a chlorine group. So I'll put my chlorine like that. And that's it, it's done. The second one, 4-isopropyl heptane, right? First thing, identify the parent name or the parent structure. Once I do that, I know hept, we're talking about how many? We're talking about 7, right? So I'll say 1, 2, 3, 4, 5, 6, 7. After doing that, I look at the attachments. What attachment do I have? At position 4, I need to put an isopropyl group. So I'll say 1, 2, 3, 4. I'll put this, let me use a red pen. I'll put this isopropyl group. And the structure is done. The next one says 2, 2, 3 trimethylpentane. So the first thing, I'm looking for the pentane. Pentane implies 5. So 1, 2, 3, 4, 5. Right? After doing that, let me put the appropriate attachments. So at position 2, 1, 2, I have 2 methyl groups. And then at position 3, I have another methyl group. And that's pretty much it. So this test was actually very simple. Okay, so the next one, 3-ethyl 2-methylhexane. So hexane is the first thing I'll consider. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The hexane part is done. Then the attachments. At position 3, there's an ethyl group. 1, 2, 3. There's an ethyl group. And then at position 2, there is a methyl group. The structure is drawn. The next one, so this one says 1,1 dichlorocyclopentane. So the first thing I start with is the cyclopentane. So pentane, when you see pent, it's implying 5. So it's cyclic. I'll be able to draw it like that. Okay, I'm not a very good artist, but I'm sure you get the point. Yeah, so that's your cyclopentane part. And then what are they telling us? They're telling us at position 1. So position 1 can be any position I choose for it to be. There are 2 chlorine groups. Therefore, your molecule is, or your compound is drawn. The next one says cis 1,2 dimethyl cyclopentane. I'll start with the cyclopentane before I consider the cis. So when I draw cyclopropane, will have 3 carbons. So it will look something like this. Alright, that's just the cyclopropane part. And then what are they telling us? They're telling us that we have at position 1 and at position 2 we have methyl groups. So suppose this was my position 1. If this had been my position 1, I would have a methyl group there, and then I would also have a methyl group at position 2. But then now, before I draw those methyl groups, there's the idea of cis they're saying. So what does it mean to be cis with reference to another thing? So what that means is being on the same side. If you are viewing this as being a 2D structure, it's quite hard to visualize. Yeah, so if you are viewing this structure, the cyclopropane, if you are viewing it from a 2D perspective, it's quite hard to visualize what it means when you say cis or trans. So I'll use this illustration. So suppose you had this is that, right? So looking at it from a three-dimensional approach, what we're saying is that those two methyl groups at position 1 and at position 2, if they say cis, what they're saying is they should be on the same side. So you're looking at it in a three-dimensional perspective. So the methyl group will be here, and then the other methyl group will be here. Now, as you are able to see, the way I've aligned these methyl groups, they're in such a way that these methyl groups are coming out of the page, but they are on the same side. That's what it means when you say cis. So how do you show this illustration I've given you? So what you do is you draw your methyl groups, but then you put them on the wedge. So when you put them on a wedge, your instructor or your professor will be able to know that you are trying to imply that they are coming towards us or towards the professor, like that. However, it's also correct to draw this, because if this happened, they would still be on the same side, right? So the other individual who would draw a structure that looks like this, who would dash both of them, would also be correct. So let's go to the next one. Oh, the next one is actually quite similar. So this time they are saying trans, same idea. So I'll draw my cyclopropane like that. And then after I draw my cyclopropane, I'll wedge one, and then I'll dash the other. Wedge one, dash the other. And then it will look something like this. Yeah, so let's do the last question. The last one says 4-methyl 2-pentanol. Key is the pentanol, right? So pentanol implies 5. 1, 2, 3, 4, 5, right? So after doing those 5, at position 2, that's where our hydroxyl group should be. So 1, 2. The hydroxyl group is at position 2, like that. And then at position 4, there's a methyl group 1, 2, 3, 4. And so that will mark the end of the video. Those are our solutions.